So in this session we're going to look at algebra. We've done the first 6 were all number, and this is now going to start the session on algebra, and we're going to look at function machines to begin with. So let me just show you what a function machine looks like. You would have seen these back in the days, the early days of your life at school. They're little, and they'd have little creatures drawn on them like this, boom, 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 boom. And you'd have an input and an output, and they'd do something inside that like times 3. And so you'd have an input, so you put any value in like 5, input it, and out comes 15. So what you also sometimes do is they say, well, this is the output, so that's the output, what's the input? And so with the function machine, you've got to do the inverse operation, so the opposite operation. So when you go the other way, you do the inverse operation. That's kind of how you solve the basic ones. So let's look at the question that we're going to face. It says this machine here literally says add 9, and it has the input and the output. And it's work out the output when the input is 12. So when I put 12 in, add 9, I get 21. And then it says work out the output when the input is 35. Put 35 in, 43 comes out. And then it says work out the input when the output is 10.5. So here now, 10.5, I've got to go the other direction, the opposite of adding 9, subtract 9, so these at 1.5. And that's kind of how you do function machines. They do get more complex, and sometimes they do involve double function machines. So it could be something like write out this in terms of a function machine. So they could say, well, what's that in terms of a function machine? And there are two things. You've got 2 boxes. First one you multiply by 2, takes you to the second one, you add 5, and you come out of an output. So you put a value in, times it by 2, add 5. For instance, if I put the value of 3 in, 3 times 2 is 6, add 5 is 11. And so they could ask you to form a function machine like that. They can also, again, go the other direction and say, well, what if they have a value? So, I don't know, let's say 21, and they want to find out what was the input. So you need to go the other direction, and you take it, you go backwards, so you do this one first. So the opposite of add 5 is take away 5, which means it's 16. So if I do that, 21 take away 5 is 16. And then divide by 2 is the opposite of times by 2 is 8. Now if that were true, then I can go back into the machine. 8 times 2 is 16, add 5 is 21. And that's how I would find it. So that's how you do function machines. Now, whilst you're still here, I'm going to go to the next slide, which is expanding, factorizing, and simplifying expressions. Okay, might as well just keep all this going. So expanding, factorizing, and simplifying. Now again, this is something that often comes up, common thing to do, so we need to know how to solve these questions. I've given you out the questions already, you can see that. So here we go. Let's look at solving some of these sort of questions, see what arises. So it says here, let's do this, let's factorize this. Now, when you're factorizing, you've got to split this number down. Okay, so how am I going to do that? What do I mean? Well, I can see a 3 in there. So I'm always going to do this. I'm always going to do, that is always going to be 3 times 1. I'm always going to have a factor pair. Always going to have a factor pair. 3 times 1y plus 3 times 5. Okay. Now, I can take out 3 from both of them. And that leaves me with 1y, which I can now leave as just y plus 5. And that's how you factorize. Okay, take a common factor out. So that's factorizing. Let's try it with this one. A squared plus 3a. So what I'm going to do, as I said, I've got a times a. Okay, and I'm put times 1 in there as well. I always have a times 1, it's always handy. So then I have 3 times 1a. You put the 1 in, you can always take it out afterwards. Okay, so now what I'm going to do, I'm going to take out what's common. I can see an A here, so take that out. I can take the 1 out, but that doesn't do anything. So now left with a plus 3. And if you expand it out, you'll see you'll get that. So now let's go for expanding and see how we do the expansions. So here, the way I do this is I have multiplication arms, what I call multiplication arms. So it's that times that and that times that. So these are multiplication arms. 4 lots of 3y, 12y. 4 lots of 2 is 8, and I'm adding. So that's how you do the expansion. Let's look at some other questions they have. Here's a tricky one. Minus 8c plus 7. But what I'm going to do is have my multiplication arms in here. So I'm going to do that times that and that times that. Notice how I do it first before I even try to solve this one. So minus 8 lots of c is minus 8c. It's no more complicated than that. 8 times 7, so 5, 6, 7, 8, so that's 56. Plus times a minus is a minus. Remember here, size and sign. So you've got to think about the size and then the sign. Okay, size and sign. Always a nice thing to remember on that case. Now we get to things like this, where you're going to simplify. So you've got terms like 9x squared minus 2x minus 11x squared plus 5x. So here you've got to tidy things up. And the way I do that is I use colour, but if you can't use colour, you can do other things, shapes, etc. I've got x squared and x squared. So I've got my x squared and x squared and my x squared here. I've got, keep the sign there, keep that negative there so you can see it. And then I've got minus 2x plus 5x. Okay, so let's sort out all what this equals. 9x squared minus 11x, because they're both x squared, just concentrate on the numbers. 9 minus 11 is negative 2. Again, use a number line if you need to. Minus 2, so look at the x's. Minus 2 plus 5 is plus 3. So it's plus 3x. And you can leave it like that as well. Let's have one more. Okay, 7y plus 5y plus 2h plus h. Oh, that looks easier. So here you can see I've got the y's are the same and I've got my h's the same. So I've got 7 and 5 is 12y, and then I've got, that's a 1 there, so a 3h. Don't try and tie them up anymore. Okay. And then next slide we'll do a bit more tricky questions on these and see what you do.